Hey guys, this is Eric Weingartner with Weingartner Racing. If you're new to my channel, let me explain how it works. I usually do 3 videos a week. You have your Sunday video, which is a tech video, and that's today's. And then you've got Wednesdays, usually a product review over some product that either I've ported or something that's come in the shop. And then Fridays is usually a race one. Now, if you're like, why am I looking at your face? Because today's Sunday, shouldn't it have something to do with some cylinder heads? It is. Today's video is actually about do you lose flow or do you gain flow if you mill your heads? And this is on the LS3 heads that you saw on last Sunday's video where I cleaned them up just to see if it improved any. And also, I did the valve job on the head to see if it improved any flow, and you get to see that too. Also, I'm going to compare this LS3 to a 243 head flow because that's a cathedral port, real popular with the guys are running 5.3s and stuff. So you get to see how much better the LS3 is versus the 243. But I do want to give you a slight preview while I'm looking at my face, and that is what Friday is going to be about. Because I have to say, and God forgive me for this, but for whatever reason, He's cursed me or something where all I think about is car stuff. That's pretty much my life. So I got a great family and everything else, but always rallying in my mind is something to do with cars. You know, I'm a cylinder head porter, so a lot of it has to do with heads. But anyway, this one's kind of neat. This is Fridays. And I'm just going to give you a little preview here, and it's behind me, so let me show you real quick. And then we'll get to the video for today, I promise. I know it's hard to see. There's the sniper from a Holly sniper, and that's a carburetor. I made them work together. That's Friday's video. All right, let's get to today's video. I'll start off with showing you how much is surfaced off the heads. We'll see the flow numbers. We'll go from there. Let's get started. This is another reason why you should also have your head serviced. This is a mill. So there's my roller surfacer. This is only just a skim cut, trying to see, but you can kind of see what's going on. The mill hit here, as you can tell where it cleaned up and where it didn't. In other words, this part was high, low, slightly low. Kind of giving away that it needed to be milled because it's not flat. I'm gonna see how much it takes to get it to 0 though. In other words, where the whole thing moves up. So right now that was 1/1000. Okay, head's milled to 18/1000. So now it is clean. Well, except for, I mean, I gotta clean it again, but deck surface is clean. By the way, it took 6/1000 to get it perfectly flat. But I was milling 18 anyway to get to Pacific's chamber size. So here we are. This one is done. So I'm gonna flow it to see if it lost anything. I don't think it did. What I mean by this is because top cut's here. You see how much material there is between it. If you start getting into the top cut by milling, that's usually when you lose flow. I don't think this will change a thing. Okay, so let's see what the milling actually did. Now, I took 18/1000 off because I was trying to reach a target, a Pacific chamber size. I think it was 65 cc's, but don't hold me to that. I can't remember off the top of my head, and the head's all boxed up that has information in, and quite honestly, can't remember, but I think it was 65 cc's we're trying to get to. But let's look at what's happened. This is cylinder 1. If you watch my previous videos, you'll remember that cylinder 1 is what it came from, 30, exactly from there. Cylinder 2, the only thing that was done was it was sandblasted and cleaned up. If you want to know more about these two, you can watch the previous video. This is what happened after the head was milled. So it took 18/1000 off. I would have thought it wouldn't have made any difference really at all because on the LS head, because of the lesser degree, there's more top cut, so it shouldn't affect it. And for the most part, it didn't. If you look, the numbers really don't change much. They're pretty close to being the same. So like 129, I mean, that's almost the same, almost the same, almost the same. It lost a little bit of CFM here at 500 lift. So it went from a 287 to 283, so 5 CFM lost there. And then you start seeing at 600 it lost almost 7. But then at 7 it lost 2. And weirdly at 8 it gained 2. So for the most part, you would say, at least on the intake side, I hate how the camera keeps moving it, that the numbers pretty much remain the same. There's not any huge difference. Now, if we look at the exhaust side, let's see if it changed much at all. For the most part, if we look at it, it's pretty much about the same. I mean, not too far different. There's 4 CFM lost there. I lost 4 there. Lost 4 there. Lost 4. So maybe the peak numbers only lost like 1. But for the most part, it's like 4 CFM loss. So if you were saying, I'm really worried about surfacing my heads whether we'll lose flow, if you're looking at it from this point, really you're not going to change more than 4 CFM. So not a huge hit, but again, this was only 18 thousandths. I would have thought, like I said, it wouldn't have taken off anything. It'd have been almost the same. But for the most part, it was. 4 CFM is not a huge change. You're definitely getting more from the compression than you did from the 4 CFM loss and flow. But there's that. Now the next thing I'm gonna do is valve job it, and then we'll flow it after. As you can tell, I've already got it done, but I'm just holding back some info. Here we go, valve job and flow numbers. All right, guys, I just got done doing the valve job on these LS3 heads. You might have saw those in the other previous video, but whatever. I don't know how I'm linking this together, so if I'm saying that twice, I apologize. Let's go ahead and show you what's been done. So this is the intake one. There is now, you see this ridge here? This is because my cutter is more aggressive. I use a 5-angle cutter. That's what it looks like for the intake side. It's a custom one. You can't order it from someone. I designed this one. But it's probably one of my more aggressive 45-degree ones because I wanted to make sure it came in because the valve job really was worn out, and it did. Because it's so aggressive, you can see this ridge it leaves here. So I'm gonna end up grinding this out and then getting rid of that eventually after it gets off this machine. And then that's how it'll leave done. But what you have here is you have an undercut. That's one undercut, second undercut, third undercut. Right here is the seat, and this is your top cut. So before, what it had was a seat, undercut, and then a radius. And if I was porting this, actually what would end up happening is, even though these two are undercuts, they get blended in, and it's really just left with like almost like a radius, undercut, seat, top cut. All right, that's the intake side. This is the exhaust side. So the exhaust side really just has the seat, and then it's a radius. And it doesn't have much. We really don't want a lot of top cut on this because it makes it sink lower when you get it to come in. So it's just enough to get it to clean up. So they're vacuum tested. They passed that, just dropping the valve in. So they're good there. All I have to do now is grind that ring out. This should make my throat probably around 89%. So the throat's gonna gain like 3%. You can go bigger, of course, but that's where that's at. And then on the flow bench. So almost done. Okay, this is what it looks like when the valve job's all done and blended. So if you saw me when I did the valve job itself, it left a ridge here because the valve cutter, my 5-angle valve cutter, is more aggressive, hence it's opening it up more. So I had to blend this out with the burr, and then I just used a 40 grit cartridge roller and went around this to make it blend in. I think this works better, of course, than of course having a ledge. That's done. At this point, and you can see where the seat line is, I lapped it in so you can kind of see. At this point, now it's ready for assembly. I just got done washing them, they're dried. It's time to put it together. So that's what we'll be doing now. Okay guys, this is what they call a valve refacer. Now this is a Sioux, which it's pretty worn out. Well, I shouldn't say worn out, it's just dirty. I love this machine. I know you're like, well, it looks like an old piece of crap. You're right, I have no idea when it was built, but it is not a piece of crap. I got this thing from a machine shop. He had moved on to a centerless valve refacer, and he sold me this for 600 bucks. And that's with this base cabinet, and I thought that was a heck of a deal. I had no idea how good it was or anything like that. The thing that makes it great is the chuck. I did replace it. If you ever get a Sioux, you'll notice they have a 3-ball chuck. I ordered this from Lacey Williams, and it's an AccuChuck, and it holds the valve at a much tighter tolerances, so the run out's not near as bad as what happened with the balls, because changing those, the balls wear out, and so on and so forth. It does take longer to change the valves, but it's not a huge bad deal. It's just something to think about. But anyway, here's how the machine works. I'm gonna kind of show you without turning it on, and then I'll turn it on. It looks like a bench grinder because pretty much that's what it is. Now, I should point this out, before some of you start knocking this piece of equipment, I looked at others. I have looked at other machines that do the same thing, other valve refacer, and I'll go tell you which ones I've looked at. Rottler, I've looked at TNS, and Quickway, and I will tell you, I have used the Rottler and the Quickway, and every time they're nothing like, not near as good as this one. So, and that's just being straight up honest. The closest one I was to it was the TNS, TNS had one that looked like a Sioux, except just like this, but it had an air chuck, and you can move this out of the way. You can actually move it to 90 degrees. So you could have actually taken off the margin or cut down a valve just by grinding it. Thought it was genius. It was also centerless, so I was like, oh, this is amazing. And it was going to cost a pretty penny, like 10 grand. Yeah, these things are expensive, new ones. He doesn't make them anymore. And I was looking at Rottlers. Rottlers are also like 10 grand. And I've used them, and they won't cut like this one. And what I mean by that is they're not near as, you can tell they're not near as concentric, and I just wasn't happy with the finish either. So it may look old, but I haven't found anything better yet. So anyway, let me set it down and I'll start cutting. Hopefully I can do both at the same time, which I doubt. I'll give it a shot here. Okay, turn on. What'll happen is this is cooling oil. It also lubricates, sprays down the valve, and what'll happen is I'll bring the grinding disc closer, and it'll start refacing it, and it'll get to where it's a clean surface again. So here we go. Hopefully you can see halfway. So you can see it grinding. What I'm going to do now is make sure I have it at 0 point, so I know exactly how much I took off. Now this is where it's going to get tricky for you guys to see, so I'm going to try to set it here. No, it won't stay. I hope this doesn't fall. God, I hope not. Alright, here we go. Oh, that's 3 thousandths. That's 3 thousandths taken off to get back to that smooth surface. And that's all there is to it. Do you have this at home? Probably not, but I thought I'd show you. Okay guys, here we are. Sorry about the video showing the flow sheet with that. The GoPro doesn't do really good at close stuff. It does better at farther away. So this is from the iPhone. But anyway, here we are. This is the valve job done. Excuse me. The one thing that's changed from these, for the first 3 tests, I used the stock valves that came with it when I floated to begin with. Now, granted, they were cleaned up on these 2 tests. In other words, they were blasted to get the carbon off. In this test, that's slightly different. Of course, it's got a new valve job, but on the intake side, it's got the Freya valve that I showed in the previous week's video. I couldn't reuse the stock one because there wasn't enough margin left after refacing it to reuse it. So that is different, besides just a valve job. So it's a valve job really in the valve. On the exhaust side, you saw me, I just refaced this stock exhaust valve, so that just got reused. So let's see what actually happened whenever the valve job got changed. If you look, it gained almost 7 CFM 100 lift, which isn't, really don't care about that number so much. At 200, it gained quite a bit more. At 300, it's more than 15 CFM. And then at 400, which is the number I really like, it went from 245 to 254, that's a 9 CFM gain. And then at 5, 283 to a 290, almost 7. And then it gains 13 here. And then it lost at 7 and gained some at 8. Now you might say, why did this happen? Well, there's a good reason for this. Remember, the only thing that I've done is the valve job. So it made it move more air. But when you make it move more air, if there's a problem in the port, such as the short side on the LS head, it can only support a certain amount of airflow, and then it starts going turbulent and flow will back up. And that's what you see happening here. And then it recovers here. But I mean, that's not that much different. So that's the reason for it. Still, regardless, if you go from where it is stock, when I started with it, this is at 600, and I think this guy's probably got a 620 lift cam. So it's going to be pretty close to this as far as flow numbers, as far as where his cam is. He went flowing 299 to 317. And the only thing is the head got refreshed. It got valve jobbed and it got surfaced. That's a pretty good gain. Now, if you look at the exhaust side, lost a little bit there, about the same at 200. 300 it gained. 177 to 178, about the same. About the same, about the same. And for the most part, maybe a little bit less. The exhaust side, it's 1 or 2 CFM less. It's pretty much what you think without doing any blend work. But it had to be done just so it to seal up. So the intake side definitely gained more. This, by the way, if you were to get a brand new stock LS head, probably, and from what I've seen, use it if low, right in this range. Now, his of course flowed worse because it had been worn out and it had carbon on it initially to begin with, so of course it suffered flow. Typically a stock LS3 actually flows this number. So you could say, well, it's all the magic you did and make it better than the stock. No, this really is about what a stock one does. Now, one of the questions people often get asked, well, how's that compared to a 243? Now, just to give you an idea, 243 is a cathedral head that came on like an LS6 head. They're really popular for people that put them on the 5.3 because if you know anything, you can't put an LS3 head on a 5.3. The bore, it takes a bigger bore, the valves would hit. You can't do it. Now, Mass does make an LS3 for a small bore, but they're pretty pricey. And to be quite honest, I don't understand the purpose of that because people that could afford to buy the Mass head probably bought a 6.0 block. So it doesn't make sense to have that, but they have it anyway. But anyway, let's look at what a 243 flows. And I have that information. So let me make sure, yep. This is what a stock 243 flows on my bench. At 232. You compare that to the LS3, 254. So it's like a 20 CFM better with the LS3. Also at 600, 264 to a 317. So much better flow on the LS3 versus the 243. Okay? Exhaust side, you can look and see. They're relatively close. But someone's going to say, well, what if you port this one? I've got that one. I've got a next sheet. This is a ported LS3. So at 400, it's 245. If you compare that to the LS3, it's 254. So it's still, even ported, flows less. I should point out this, by the way, this is only a 202 valve. Hold on a second, let me turn off the air conditioner. So this is only a 202 valve compared to 216 on the LS3. If we look at 600, it's a 308 versus a 317 stock. So you can see it's still worse than that. Now the exhaust flow is considerably better because it's been ported. So we look at 4, it's 208 or 209 compared to the LS3 is only 176. So the exhaust side ported definitely is better on the 243 than the stock LS3. However, you port an LS3, you'll get the same numbers for the exhaust. They're about the same. But then you can't match the intake flow. The bigger valve, the raised up port, it's just better on LS3. If you port these ones, you're gonna get about 370, 376. I've seen some that have gone 380s. So definitely these pick up more than an LS3. But again, those only fit on the 6.0 block. They won't fit on this. But these can fit on the 6.0 block. So there's that. Now the next question is, well, how does an LS3 then compare to, say, an LS7? Because I have that numbers too. Let me just move a sheet here if my fingers will grab it. Okay. This was the LS7 heads. So if you compare this to the LS3 again, LS7, 400, 303, and these are just CNC ported from factory. 304 to 254, obviously better. 600, 361 to a 317, much better. Same with the exhaust, that's pretty close to what you just saw from the 243. So point being is it's a much better gain still even for these, but I'm about 90% certain that this won't fit on that block because it takes the 4155 bore. But just gives you an idea comparison wise. For the record, you can port this head to outflow this one easily. On the at least stock LS3 ported will outflow the stock LS7s. Now aftermarket, that's a whole different story. Now I do want to do one more thing to save you guys from yourselves as far as LS guys goes, because I keep hearing it often about there's no small block heads that flow better than the LS heads. Okay, this is the most popular head I sell. It's my small block Chevy Dragon Slayer 242 cc's. Okay, now it's ported, granted, it flows 339. At 600, it's 324. Okay, this is your LS7 again. It's 317 at, LS3. It's 317 at at 600 compared to 324. Okay, granted it's ported, but the only reason why I'm pointing this out is because there's so many LS guys that believe that there's no small block Chevy head that flows as good as the LS heads. Incorrect. And this isn't even a fancy head. This is the one I sell the most of, but it is not top of the line, the bad boy of all bad boys. It's not. It's a 23-degree head, basic, doesn't require shaft rockers. And the only reason why I mention this because I hear so often No, the LS heads outflow the small block heads. Stock ones, yes, but it's not the same in the aftermarket. And then you get the same thing, like you're trying to compare a stock head to an aftermarket head. Well, I mean to tell you, when you go to the drag strip, you're more likely to find a small block Chevy with an aftermarket head than you are with a stock head. And I'm just being serious. And I'm trying to save you from embarrassing yourself when you say, no, there's no small block Chevy head that flows better than LS head. They do. Now, there's of course way differences, but I'm just trying to make sure you get this straight. Because I did say this flows 370, and of course that would beat this. If I port this one, it's going to outflow this one. But again, that's 15 degree. And if I get a small block Chevy 15 degree, we'll beat that one. I'm just trying to save you guys from yourself. I don't want you to sound stupid when you say stuff. But anyway, that really will conclude this video, except for I want to make one random rant. But if you want to stop right now, you can go ahead and cut this video off and call it quits, because the next one actually has something to do with food and one of my pet peeves, and I thought I'd just bring it up, and it has nothing to do with this video, but I'm going to bring it up, and if you want 2 minutes of bonus things, I'm going to give it to you. Okay, before I start, this has nothing to do with tech at all. This is just me being rant, because I can't, you talk about a pet peeve, this is the one. My wife had her birthday yesterday, we go out to eat. She picks wherever we want to go eat. I don't care. Doesn't bother me at all. Wherever she wants to go, that's where we're going to go. However, I have a problem with restaurants. You're like, what do you mean? Look, I have one rule with food, really. Well, two. Don't give me something that's going to make me sick. And also, the second one is this. Simple. You don't mix a salty food with a sweet food. You're like, what are you talking about? Meat isn't meant to be sweet. It's not. It's supposed to be salty. Now some of you can argue, no, orange chicken, blah, blah, blah. That's cool. You can have that on your menu because there's going to be people that eat it. But don't make that the only thing on your menu. We go there and this place has a menu that's this big. So it's really short, one page deal, simple. I'm not going to name the place. But it's one page. It has something like 8 options. I'm not joking. It's an expensive place, not cheap. It has 8 options. I'm trying to figure out what I want to eat, okay? And a whole bunch of them, like normal foods, I'm like, salmon, all right. I'm like, look, I'm looking at the menu, and there's salmon, all right, sweet, easy pick. And then what do they say? A sweet glaze on the salmon. Salmon doesn't have to have a sweet glaze. Don't put sweet glaze on the salmon. Now, I wouldn't be bothered by it if below it they'd had just wood-fired grilled salmon. Awesome. But when your only option's sweet salmon, I'm not getting sweet salmon. And then the next one was it was shrimp with a creamy honey sauce. Again, wouldn't have been bothered if they'd been another salmon or shrimp option that wasn't sweet. Steak. Luckily, they had something for that, but that's what I ended up getting. However, that one also had, and the only reason why I got it is because they had a house special that wasn't on the menu that was regular steak. It was Cajun, which was like, thank God that'll be salty. But on the menu was a sweet steak. Drove me crazy. Now, why do I even bring this up? Because a couple weeks ago, we went to Red Robin. I'm a burger guy, obviously. Looking at myself, you can clearly tell. There were so many burgers on the menu that sounded delicious, and they had to ruin them with sweet stuff, something sweet. Because I'm like, bacon cheeseburger should be simple. Anybody can do a bacon cheeseburger. No, we have a sweet smoked bacon. No, you don't put sweet bacon on a burger. If you do, have an option where it's got a regular piece of bacon for most of the rest of us. And it was like half of them had some Sweet Tavern sauce on a burger. Stop putting sweet stuff on meats. Okay? It's very simple. You're not being creative. You're just mixing stuff that we wouldn't have put together to begin with. I know some people are going to argue with it. That's fine. As long as they have 2 options, I don't care. But half the stuff there, both the Red Robin and the place we ate, I couldn't eat. I shouldn't say I couldn't eat. I'm not picky. I end up eating. It's just something I wouldn't enjoy spending 40 bucks on. That's my rant. So restaurants, if you happen to be listening to this, or maybe one of you car guys work at a restaurant, and your boss comes up with a great menu item that includes something sweet on a piece of meat, you tell them at least have an option that's not sweet. This is not that hard. That's your rant.